What's up YouTube? My name is TheLazyTryhard, and today we are going to be continuing our libdx tutorial series. And today, this is kind of a continuation of the 16.1 tutorial where we covered the tiled map engine and how we can kind of use it and kind of make our own cool looking maps. So if you weren't here, go watch that video. It's probably not going to be in the description because, as you can see by my username, I'm a little lazy. But on the off chance that it is, go check it out, or just kind of check out the latest video in the playlist. So we basically just learned how to create this and how to color in everything with different tile sets and stuff. So today what I thought I'd do is kind of show you guys how to actually draw it into libdx and kind of how to interact with things and like pick up on certain IDs and stuff. So we're just going to kind of show you, I mean, you guys know what this looks like, but if you haven't, I mean, again, we're using the basic tile system that we have been using. It's kind of laggy. It's not really that cool. I mean, it's like, whoa, you made your own terrain, but it doesn't have any, like, you know, you couldn't implement this into an actual tutorial game or anything like that. So it was just kind of for play and stuff. So today we're actually going to move the map and render it and draw it and do all that fun stuff. So without further ado, let us begin. So last time, again, we initialize the map and the renderer just to set everything up. So how do you actually render this stuff? And you could just think, oh, well, you just do render.render, right? Well, I mean, yeah, okay, that's kind of right. But we have to do a little setup. So first, we're going to toggle the comment on the tile iterator just because we don't need this anymore, and the trees. We're going to draw that in the tiled. So really all we want to be drawing is the player and the enemies. So we keep all of that. And so if you, I mean, you guys can run it. It's just going to have a black screen. And you guys know what that looks like. So what you're going to want to do is do the following. I know this is going to be crazy. 2 lines. Render.setView. So we're going to set the view to the cam. So we know, the tiled map knows how to render. And next you're going to do renderer.render. Whoa, crazy. If you run that, you're going to hit play and you're going to hit OK. And you're going to get, whoa, a beautiful map. How is this done? Crazy, right? Really not that crazy. I'm no magician, I promise. So it renders it down here. This is 0, 0. So it renders it as 0, 0. And it goes all the way up to so we did, I'm trying to remember the resolution, but we did 20 total tiles at 64, so 20 times 64, I think it's like 1280. But basically, again, these are all 64 by 64 tiles that we kind of drew out, and as you can see, it kind of corresponds with everything in here. So that's awesome. Hooray, whoop-de-doo. When we run into this tree, though, nothing happened. Like, we want to know, or we want to like interact with that tree. So the next thing I'm going to teach you guys is actually how to interact with this and how to actually like implement collision detection on tiles that you want to have collisions. So we're going to do that next. You're going to want to do the following. Make an array list of rectangles. Oh gosh. Make an array list of rectangles. I don't know what just happened there. Of rectangles, and we're going to call it bounds. And these are just going to hold all of the rectangles, kind of how we've done it with the trees, but we're not actually going to do it with trees anymore, because actually we don't even need this step because we're not even making trees anymore. So, you know, optimization is very important. So we're going to say bounds equals new array list, and it's going to be a bunch of rectangles. You got to initialize it or else it's not going to work. And we're going to do a 4 in, actually, I'm going to show you guys a quick little tip. So if you type 4, hit control space, enter, it does it for you. So usually right here, what you would do is you would basically, like, you would put your map width in here. Since ours is 20 by 20 and we're only dealing with one map, we don't have to do that. But usually you want to have like a variable for that that actually like takes care of that. But we're not worried about that right now. So we're going to do 4 again, and we're going to do int j, and I'm going to show you guys why we do a double loop as opposed to a single. So we're also going to make this 20, so the length and the width. So the two dimensions, so if you had a width of 40, you could do 40 by 20 or vice versa. You just kind of got to play with it. So we're going to now actually deal with kind of the harder stuff in all this. You're going to first make a tiled map tile layer, cur equals, you're going to cast it into a tiled map tile layer, and you're going to do map.getLayers.get, and it is the first layer. I'm going to explain this. Nobody freak out. I know y'all are freaking out right now, but don't. I'm going to explain this. So, we have our two tile layers, right? The terrain tile, which we don't want to deal with, that's just for cosmetics and stuff like that for right now. But the trees, we want to interact with that. So we have this tile layer, and we want to access that tile layer within libdx. So that's how we do it. Map refers to the actual tiled map. We get the layers of that tiled map, and we get one. You could also type in trees, and I think it would work. But since we're dealing with so few layers, we're just going to do a 1, because terrain is 0. Basically, you start at the bottom, and now you're here. Stupid joke. But trees is the 1. So it goes 0. If you want to get the terrain layer, you'd be 0. If you want to get the regular trees layer, you get 1. So basically, all we're doing in this line is accessing that layer from libdx. So what you want to do next is initialize a cell, and it's going to equal a new cell. And these cells are basically each of these tiles, or kind of like each of these tiles and all the data that it holds. So if we go here, this cell all the way at the bottom down here, it's going to have a couple properties. It's going to have basically its index, which is 0, 0, the coordinate of where it is. It's going to hold the tile ID, which all these tiles have different IDs. This tile will have an ID of 0, this will have an ID of 1, and so on and so forth. You can also get into these things called tile properties, which if you right click it, you can add some values and stuff. But that's for more complex stuff, which we can get into later. But right now we're just going to deal with basically everything in this tree layer is going to have these same properties. So we're not going to really deal with that. But this cell is basically that tile data type within it. So if you do cell equals new cell, you're going to now get into the kind of complicated part. So if cur.getCell, so we're getting the cell from the map, and we're going to do ij because we're wanting to access the xy coordinate of this. If cur.getCell does not equal null, so basically, dang it, get rid of that. If you turn off this layer, the terrain layer, and this cell doesn't return a blank cell, it's basically going to return that cell. So this is a null cell, this is not. All of these are null, this is not, because it has a tile in it. I think you guys can understand that. So that's what this line is doing. So if it is not null, then we want to add a rectangle to this array list so that we can perform collision detection on it. So we're actually going to do cell dot equals cur.getCell ij. So we're going to set the cell equal to that. We're going to, just for debugging purposes, system.out println, and this will be a good visual for you guys. We're going to print out I plus comma, and you don't actually have to do this line. I'm just doing it for debugging purposes. So it's going to print out the location of this of the object, and it's going to then print out the cur.get it is actually, let me see, cur.get, yeah, what's the problem here? Cell.get tile.getID. So I'm gonna explain most of this in a sec. That should work. That should be good. There we go. Sorry. Don't forget your T's, everyone. So this is just going to print out the location of the tile that is not null, and it's going to also return the ID. So basically whatever differentiates it between the two tiles. So then we're actually going to add it. So bounds.add new rectangle, and don't get freaked out here either. So we're going to do I times 64, J times 64, 64, 64. So we're adding a rectangle. So if we want to add a rectangle at say 0, 0, because that's 0, 1. Actually, you know what? I'm just going to run this and kind of help you guys visualize it very quickly. So we printed out all the values of the cells that have that are in the tree layer. So at 0, 1, which is, move over there really quick, 0, 1, that's a rectangle. So that's a valid rectangle that has what we want in it. That is a part of the terrain layer, the trees layer. So that we caught that cell, and now we're adding it to a rectangle to that, so that we can perform collisions upon it. We next go to the 0, 12, which is kind of up there, and then we go to the 2, 2, which is also it's this tree. So all these tiles are getting put into it. So also, if you notice, the IDs are different because the 2 represents this stone, and the 57 represents the tree. So that's very important as well if you want to know what the IDs are doing. So that's awesome. Now we have the bounds, and now what we're going to do is actually put collision upon this. So go up to your render, and after you do player update, we're going to do if we're going to do a for loop that kind of deals with everything. So bounds dot size, and this is kind of what we've done before, but we're just going to do it again. So if bounds dot get I dot overlaps player dot get bounds, then we're going to say collision happen. So system dot out dot print, dang it, print ln, don't forget the T. We're going to say collision detected. And next we're going to call the player.readjust method that we made a long time ago. So it's actually going to readjust us so that we're not in that collision. So if we hit OK and everything prints out perfectly, we're going to walk over to this tree, and fingers crossed, we actually get detection. So detection! Our system.out is freaking out. We can go to any one of these trees, or anything within the tree layer, and it's going to detect it. So this is awesome. So now we can have real collision detection. We don't have to make all these trees and work really hard to do that. And just to show you guys how flexible this is, if you wanted to put more trees in here, or let's put, what's a good, real trees. Okay, yeah. So if you wanted to put more trees in here, you can, and you don't even have to worry about changing your code at all, because it's still going to work, because it's still going to detect all of it, and it's going to be handled perfectly, because that's how I do tutorials, perfectly, right? Wrong, but it's going to be okay. So, oh gosh, I've actually put a tree within the actual spawn location, whatever, but you guys get the point. So you can add whatever you want with these trees and stuff, and you'll have collision. It'll all work out perfectly. So that's it for me. Thank you so much for watching, guys. I'm glad this tutorial went better than the last one. I didn't have any stupid mistakes as the last time, so I apologize for that previous video, but I hope you guys get the point. This is really complicated. It took me a really long time to understand it, so don't, beat yourself up if you don't get it the first time. Play with it, mess around, do stupid things with it. That's what I always recommend to learn all this stuff. So again, if you want to do that, it'll really help you guys understand the concepts behind all of this. So, again, thank you so much for watching. I think I've done this outro like 3 times now, but thank you so much for watching. Please rate, subscribe, comment, and I will see you guys in the next video.